Hello, my name is Phil Gilliam and I am the president of Antibody Incorporated. I'm here today to explain to you exactly what Antibody is and what the customized bodyguard devices can do for you in reference to exercise physiology and injury prevention. So, what are the bodyguard devices actually going to do for you? Well, let me show you. The bodyguard devices themselves, as you can see here, outlined in black on the muscular chart, are designed to deliver compression, support, muscle heat circulation, strain distribution, and impact absorption. The individual devices themselves are designed to accommodate musculoskeletal injuries to the shoulder, the chest area here, the bicep area here, and if you bear with me, we're going to go back and forth, the tricep area here, the upper back region here, all the musculature and the connective tissue in the upper back here. And again, bear with me. We're also going to accommodate injuries to the groin and all its insertions here in the pelvis, right in this area. We're going to do the hamstring area here in the rear of the leg. Just bear with me. All the musculature and the connective tissue here in the hamstring area also. The hip and the lower back right here. So you have athletes with lower back strains or fatigue in the lower back, hamstring, hip injuries, and even hip flexor injuries here. The knee area here, which is also going to include the lower thigh and the upper calf region here, along with the connective tissue in the knee here. The shin area here, which sometimes athletes have when they have shin splint problems here. The ankle area, and also in the reverse it would be the Achilles tendon. The elbow region here, which includes the lower bicep and the upper forearm area here. And the wrist for injuries like carpal tunnel syndrome. Now, most of these injuries that we spoke of here, and most of the injuries that these devices accommodate, are basically caused by impact trauma, something slamming into you, overuse, or a single violent strain or sprain on the musculature and connective tissue of a particular region of the human body. Now, the theory behind these devices that we've shown you here is a theory I designed called stored elastic energy transfer. Again, stored elastic energy transfer. It sounds like a mouthful, but the theory itself is quite simple. Rubber, or any rubberized material, has got elastic energy. I'll give you an example. That's why you can stretch rubber to enormous size and then it returns right back to its resting state. So rubber stretches and attaches with an ability called elastic energy. Muscles also expand and contract. So, if you attach a rubberized material to the surface of the body while it's stretched, you can actually transfer elastic energy from the rubber directly to the surface of the human body. And what is that good for? Two things. If you're traversing a muscle, it works in concert with the muscle. So if you have, for example, a pulled hamstring, a quadricep strain, and you've got the lower body shorts on here, the bodyguard shorts shown here, and they're designed with the compressive design that we designed them with, then what you have in effect is a thin film of muscle over the hamstring, over the quadricep, attached to the surface of the hamstring and the quadricep to work in concert with those damaged muscles. And you might ask, well, what does that do? Well, it works like additional muscle, essentially. It's working like additional muscle over that portion of the body. What else will it do? It's going to assist the muscle when they expand and contract. It's going to increase the amount of torque that muscles create. And that's what muscles do when you change direction, when you run, when you jump, when you come to a complete stop. When you try to make an explosive move, your muscles are expanding and contracting explosively to create torque. Well, when you expand and attach rubber to the surface of the body, you actually increase that mechanical torque. So you're working with the muscle to provide additional mechanical torque, Why is that important? It's important because it can enhance physical performance. You've got the ability that your muscles have normally, and now you've got a thin film of rubberized material creating additional torque, which can actually enhance your physical performance. Another thing that this particular design will do is it will reduce muscle vibration. You can look at all of the thick, powerful muscles you have in the lower body. Just look at the quadricep muscles here, the tightly drawn muscles in the hip area and in the pelvic region here. When you run, jump, jog, whatever, those muscles vibrate. They move back and forth. When they vibrate, they cause a generation of lactic acid. Lactic acid is the burn you feel when you're running. That muscle vibration also fatigues you. So if you have the lower body covered with the bodyguard shorts, you're going to reduce that muscle vibration, in some cases, almost 50%. So what is that? Why is that important? Why would that be important? It's important because now you have reduced that muscle vibration. So whatever activity you're engaging in, if you're playing basketball, if you're playing football, if you're a sprinter, if you're a distance runner, you can engage in that particular activity for a longer period of time at a higher level because you're not becoming fatigued. That is very important. Another thing that compressive energy transfer will do is that it will increase blood flow. And let's stay right here in the groin area. If you've got a damaged quadricep muscle here, and let's just say you've taken an impact to the quadricep and you've got bruising there, you've got a thigh bruise. All that is damaged tissue. In order to heal that tissue, you have to increase blood flow. Well, a rubberized material is going to raise muscle temperature and increase that blood flow in that area to accelerate the healing process. So that's another thing that it will do for you. It's going to accelerate the healing process. And again, overall, it's going to support, all the connective tissue and the musculature in the lower region here. So that's specifically what the devices are designed for and what that theory delivers. How do we do it? When we design a customized brace, what we do is we take specific measurements, your specific measurements, so every one of the devices is an original just for you. After we take those measurements, we feed them into a little algorithm that we have designed for each brace. So the angle shoulder brace has an algorithm. The elbow brace has an algorithm. The shorts have an algorithm, the knee, the ankle, and the shin. We feed your measurements into that algorithm, which reduces the size of the brace. So if I were making these shorts for you, I would take your measurements, but the product we delivered to you would be a smaller version of your body. What your body would look like if it were smaller. Why? Because the material not only has to attach to the body, but it has to attach while it's stretched. So if I make it smaller than you, it stretches and then attaches, anchors itself to the body, and it will not move or slip even after heavy perspiration, so we attach it in that stretched state to deliver that stored elastic energy directly to the surface of the human body, using the algorithms that we've developed for each brace. Now, why is the material important? The material that we use is a blend of neoprene and butyl rubber. Neoprene is a material that they use in wetsuits. It raises temperature. It also, if it's designed right, has a tactile surface. Tacky means it attaches to the skin. So you not only have to have it compressed, but you have to attach. So the material that we use is the blend of neoprene and butyl rubber, and it's perforated. What is perforated? Perforated means it has holes in it. Holes in the device to allow the skin to breathe, conduct sweat to the outside of the device, and still stay physically attached to the body. So what this thing is it becomes a part of the body. So if it's the shorts you're using, it's like you've got a shock absorber around the lower body. If it's the shoulder brace that you're using, it's like you have a shock absorber around the shoulder area, the chest, the bicep, and all the other musculature in the upper back that we discussed. If you purchase the elbow brace, you've got a shock absorber around the elbow joint to work in concert with the musculature in the lower bicep, upper forearm, and all the connective tissue in the joint. Take pressure off of it, create torque, raise muscle temperature, and connective tissue temperature, so if there's any damage there, to promote healing. Same thing with the wrist. If you've got a condition called carpal tunnel syndrome, support the wrist, raise the temperature if there's any damage or inflammation in there to move blood to promote healing, and provide significant mechanical torque to take pressure off it if you have a repetitive exercise that you're engaging in, such as typing on a computer or using your wrist repetitively, where you'd be in danger of having an overuse injury that causes carpal tunnel syndrome. Same thing with the knee. If you've got knee instability, if you've got some damage, or if you're rehabbing from ACL injury or any MCL, PCL, or if you've got lower quadricep strain, or if you've got an upper calf strain, you can use the open patella knee brace here to attach to that portion of the body, raise the temperature, support the tissue, and take significant pressure off the knees. Some customers, in fact, use the knee brace even if they don't have injuries. So if they're about to engage in a high-risk activity like skiing, starting a jogging regimen, starting a running regimen, they use the braces to make sure that they never get injured. Over to the shin area, and I will say shin, but also the calf area if you have a condition like, and I'll go down to the lower drawing again. If you have like a calf strain or rehabilitating from a calf injury, if you have a problem with the Achilles tendon, the upper portion of the insertion of the Achilles tendon right here, the lower body shin splint has been used for shin splints themselves, upper calf injuries, and any kind of concern with the Achilles tendon here. And lastly, the ankle brace for any kind of instability in the ankle, ankle sprains, ankle strains, impact trauma to the ankle. Even again, lower portion concerns with the Achilles tendon's insertion on the heel right here. So that gives you a bird's eye view of what the devices can do, have done.